Good morning, guys, ladies and gentlemen. This is part three of our lesson on gases, basically, the continuation of our lesson on Boyle's law. Now, we mentioned earlier that the constant is equal to the product of the pressure and the volume. And this basically means as the pressure of a gas increases, the volume of that same gas decreases at constant temperature. All right, so I'm repeating what I just said. I just said that according to Boyle's law, as the pressure of a gas increases, the volume decreases at constant temperature. All right, now Boyle's law is obeyed only when the density of the gas is low. I repeat it. I'm saying that Boyle's law is obeyed only when the density of the gas is low. So for real gases, okay, real gases such as oxygen and hydrogen. All right. For real gases such as oxygen and hydrogen, Boyle's law is obeyed only at normal temperatures and pressure, but not at high pressures. I'm taking this again. For real gases such as oxygen and hydrogen, Boyle's law is obeyed only at normal temperatures and pressures, but never at higher pressures. So, gases which obey Boyle's law are perfectly called ideal gases. Okay. All right, guys. I just mentioned that gases which obey Boyle's law perfectly are called ideal gases. All right, so we want to proceed by looking at some graphical representations of Boyle's law. Now, you can see that there are three diagrammatic representations of Boyle's law we want to depict. Boyle's law can be represented graphically in several forms. We're just looking at a few. For instance, where we have pressure against the inverse of volume, our graph becomes linear like that. Okay. Now, where we have the graph of the constant against pressure, because we just said that P times V is equal to K. So you could as well say K versus P. So where you have um, the constant PV against the pressure P, your graph representation of Boyle's law becomes a straight line that way. Okay, and then where you have P versus V, or pressure versus volume, you have a curve that way. So these are three representations of Boyle's law graphically that we need to have sight, or we need to have awareness for. Okay, guys, let's take our first example under Boyle's law. All right, we have a question here. The preamble says a fixed mass of gas has a volume of 60 cm cube at a pressure of 80 centimeters of mercury. And now the question says calculate the pressure of the gas if the volume is changed to 40 cm cube at constant temperature. Okay, so let's attempt to answer that question as we have seen. Now, for example, 1, you realize that the fixed mass of the gas has a volume of 60 cm cube, and that tells us that that's the value for volume. Okay, so we have a volume of 60 cm cube. Again, we are also given that this volume is at a pressure of 80 centimeters of mercury, and that is a pressure. So our pressure is 80 centimeters of mercury. All right. Then again, we are asked to calculate the pressure of the gas. So we are asked to find V2 when the pressure is reduced from 80 to 40, sorry, from 60, when the volume is reduced or changed from 60 cm cube to 40 cm cube. So we have our V2 given to us here as 40 cm cube. All right. The question says calculate the pressure. Thank you. Question says calculate the pressure. So in accordance to Boyle's law, we understand that um, the constant is equal to a product of pressure times the volume. So in so doing, what happens is that we're going to equate that pressure and volume against pressure and volume. So that's basically Boyle's law. All right. So this is everything based on Boyle's law. So we just have to input our values here. All right. Since our unit is already in cm cube and our pressure is also measured already in centimeters of mercury, we don't need to change it anyway. So now we are asked to find P2. So from here, we know that P2 is equal to a product of that divided by V2. So we just put in our values. We just put in our values and then we can solve for P2. So I hope you've solved for P2. So solve for P2 now and give me an answer for P2. Well, if you should do it right, then your pressure of the gas should be equal to 120 centimeters of mercury. So solve it and confirm that for me now. That is example 1. All right. So let's continue to example number 2. Example 2 says the pressure of a fixed mass of a gas of volume 100 cm cube is doubled at constant temperature, and we are asked to calculate the new volume of the gas. So let's try that. Okay, so now we know that from Boyle's law, P1 V1 is equal to P2 V2. All right. Now this question says the pressure of a fixed mass of a gas of volume 100 cm cube is doubled. Okay, so what it's trying to tell you is that your P2 is double of P1. That's what you are. So fixing this in there, or fixing this in there, you now have P1 V1 is equal to 2P1 V2. All right, where 2P1 is double of the pressure given to you as P2. Okay, so by finding the new volume or making the new volume V2 the subject, you end up having V2 to be equal to P1 V1 all divided by say 2P1. Okay, so now where we know that um, our V1 is equal to 100 cm cube, then we know exactly what could happen. The P1 can cancel out, and now we have V2 is equal to V1 divided by 2. So all you have to do is divide by 100 by 2 and you have your new volume. So your new volume into is equal to 50 cm cube. Thank you so much for your time. And this brings us to the end of part 3 of our lesson on gases. See you.